turn the, anybody? All right, thank you, Ian. All right.
So Boyd mentioned that there's not a lot of people telling you how to do Docker, and that's exactly what I'm going to do. I'm going to tell you how to Docker, and specifically how to try and fit maybe an existing application that's not very Dockerish, not very 12-factor-ish, and try and squeeze it into a container and improve it by using it with Docker. So first of all, who am I? I still think of myself as a sysadmin, even though people like to call me things like root things like cloud engineer or DevOps. And I work at a company called Bluebox, and we do private cloud as a service. So if you're interested in using a private cloud, but you don't want to run one because it's hard to run one, that's what we do. So talk to me. And then what I want to talk about tonight is kind of two things. Factorish is the kind of tool set I've developed, and Factorish is kind of the mindset I sort of was thinking about it. So, there's a lot of noise in the Docker community, a lot of loud noise, telling you how you should do things and telling you very aggressively sometimes that, you should only run a single process. You should have like tiny little small images, things like that. And that's fine if you're in like a unicorn, greenfieldy kind of place. But for most of us, we have like existing apps and we have existing tool sets and we have to continue to work with them. And also a lot of this stuff, it's actually like angry opinions in the community and not actually Docker themselves saying it. Docker themselves will tell you, run a large image, they'll tell you run multiple processes. So I've been thinking about this for a while, and I sort of started thinking about the concepts, and then started building some tooling around it. And so basically Factorish and this whole 12-factor, which obviously is a play on factor, which sounds exactly the same, so it's stupid when you say it. It's kind of my way to bring some pragmatism to this mess and just say, look, we have apps that we need to run, so let's see if we can run them in a smarter way using Docker. So is everyone familiar, at least passingly, with what the 12-factor manifesto is? Everyone's seen 12factor.net. Show of hands if you know what a 12-factor is. Okay, good, most of you. I don't have to explain it too much. So it's basically a methodology for building modern web apps in a kind of new, cloudy, microservice-y kind of way. The TLDR of the entire thing, which if you haven't been there, go to 12factor.net and read through it, it's interesting stuff, this is how to write an app if you want to write it on Heroku. It's basically the very short description of it. But what I find is even if you're not planning on running in a PaaS like Heroku or even running in a Docker container, there's still a lot of interesting things in there which you should probably read up on and take away. A lot of modern init systems want you to run processes in the foreground, say, and that's one of the things 12-factor talks about. So even when you're working on current apps, writing config management to run current apps, kind of think about some of the things in 12-factor, and it may help you. Anyway. So basically, when you Dockerize a 12-factor app, you're grinding up that unicorn and packing it into a can, and then you're going to ship that around. Your app, though, isn't a unicorn. Your app is more like a donkey that's so weighed down he can't actually touch the ground. So you want to ask yourself, can I Docker this? And with thinking about the 12-factor mindset and using tooling like Factorish, the answer is probably, but not always definitely. So there are definitely some cases where you don't want to run it inside of Docker, specifically like an actual database with stateful data and stuff like that. But for a web app that talks to a database, that will probably run just well inside of a Docker container. So your app is probably pretty old. It runs on a server that's lovingly handcrafted. Some of it might be in config management, but probably not. It's probably hand deployed to the various stages, and development probably looks very, very little like production. But what we can do is we can take your app and we can grind it up into a paste, and we can stick it to a can. And apart from the label, that can doesn't really look any different to the can of unicorn meat, right? And so that's basically what the Factorish stuff is about. It's about saying, let's think of the container as our app, and let's make sure the container acts and behaves like a 12-factor app, rather than trying to heavily refactor your applications and retool stuff. You either think of the container as being your app, or at least it being the built artifact or executable for your app. And yes, it is kind of polishing a turd, but you're probably running this app because it makes you money somehow, and you want to keep running it. You probably want to make it better and make it more efficient, more usable. And yes, it's poo in a box, but you can't see into the box, so you don't actually know there's poo in there. As I said, you've got this app, it makes money, but maybe it's hard to run, maybe it's hard to maintain. You kind of like the idea of having like a runtime configured, immutable application with some buzzwords. And then you also want to think about, like, do you want to spend a lot of time on your legacy stuff, or do you want to work on what you're doing in the future? So there's this idea of bimodal IT, which is stick a fence around your legacy stuff and just ignore it and leave it running the way it is and focus it on what you're doing in the future. And I think this kind of stuff is kind of that middle ground getting towards during the future. Maybe you can find some small easy wins and pull them in under the fence into how you're doing things. And that way you can sort of slowly start to introduce your org to the new way of doing things. You don't just show up one day and say, hey guys, we're doing Docker for everything, and then you spend like 18 months building up a platform to actually be able to do Docker stuff and nobody knows what's going on. And so taking what you have existing, like you probably have pretty good config management at this point, I hope, and doing config management and some Docker stuff together, it isn't a huge shift, especially compared to trying to do everything in Docker. And so, as I said, it's a nice, easy way to like slowly ease yourselves in your org into starting to think about doing things in a more modern way. So we're going to actually go through the 12 factors now. The first one is a pretty simple one. I hope everyone already has all of their code in a source control. If you don't, you should probably like leave right now, because you shouldn't even be talking about Docker and other things. But what you should also be trying to do is putting all your scripts to build, deploy, and run your application into source control as well. And preferably, you want to actually put it in the same source control repo as your app. And that way it's versioned with your app, and it's deployed with your app. Sorry, you deploy your app with it. And anytime you want to deploy, say, version 1.3.2 of your app, everything is in that Git hash that you're accessing, including all the tooling to deploy. So you're always going to deploy version 1.3.2 every single time. And that's pretty cool. And even if you're doing, you're not doing Docker, you're doing Chef cookbooks and stuff like that, there's the idea of an environment cookbook, which is kind of the same thing for Chef, where you put all your cookbooks into the code repo itself. And then the other thing is, obviously you want to have a Docker file in there, because you're going to be building a container of some sort. You also probably want to have a Vagrant file in there. And the reason for that is you have a bunch of deploy scripts, and chances are you can run those through Vagrant because they're shell scripts, or they're Chef, or they're Ansible, or something, and Vagrant supports doing all of those things. And that way, immediately your dev environment starts to look a little bit more like your other environments. And also, there's some, you can use Docker Compose, that's fairly new, but then that's not really helping you right now getting your production to look, your dev look more like production. It's actually making it less like it. Whereas with Vagrant, it's using the same tooling to deploy to dev and prod. And you're also ensuring that everyone has the same experience, right? Because now Vagrant is the thing that gives you that level playing field, whether they're on a Mac or Windows or Linux or whatever. Especially if you're using the same provider, so using VirtualBox or whatever. It's like exactly the same for everyone that runs it, which is super useful. And it means that every time now a developer does dev work, they're actually testing your deploy scripts. They're testing how things work. So you're shortening your feedback loops. So the tooling I put together around this is called Factorish. I've mentioned that, and I kind of designed it to try and allow you to pretty much copy and paste it into your code repo with very few changes, and then start like using bits and pieces of it. Our second factor is telling us that all our dependencies should be both declared and isolated. So we're So we want to declare all of our dependencies, and we want to completely exactly declare them, and we don't want any reliance on system packages whatsoever. I mean, obviously there's going to be like libSSL and stuff like that. You probably want to depend on that. You don't want to recompile that shit, but when it comes to the actual application, you don't want to be relying on like system Ruby libraries and stuff like that. And then the dependency isolation is basically you're running a tool during the build to ensure that all dependencies that you've declared are actually jailed and isolated as part of your app, so that you don't have any dependencies leaking in from your system, like a random Ruby library sitting in your system's Ruby that you're using instead of what it should be. So example is with Ruby, you've got your gem file, which is your declaration, and you've got your bundle install, which is your isolation. And with Docker, you've got your Docker file, which is your declaration, and you've got your Docker build, which is the isolation. And the interesting thing with doing Docker file for your declaration is you can actually rely on system dependencies because you're declaring them and sticking them in the container with your app. So they're kind of becoming part of your app. And they're not reliant on what's on the host, and you're never going to have anything leaking from the host in. And so you can see from this is an example Docker file, and you can see I'm declaring my dependencies. I'm saying I'm using Python 2.7. I'm saying I want supervisor installed. I'm saying I want etcd conf installed, and I'm also saying I want to do a pip install of any of my requirements inside my app. And so that's our declarations side, and then we just do the Docker build, which is our isolation. So our third factor is that all configuration should be done by environment variables. And when I say all configurations, I don't actually mean all. I mean things that, the good way to describe it is like, can I open source this code right now and not be sharing any secrets or passwords or anything like that? If the answer is yes, you've probably done enough. You don't want to put all of your application configs into environment variables. Otherwise, anytime you run it, you're going to have like a massive long string of things you want to configure. So any of your application configuration stuff that doesn't really change between environments, doesn't really change between dev, test, prod, leave that in a config file or whatever the way you've been doing it. And just focus on passwords, URLs to databases, stuff like that. Stuff that's going to change frequently, and stuff that's password, secrets. And so here's an example of with your Docker run -e text equals bacon. That's basically passing in an environment variable to the Docker container when you run it. And then two ways to read that and write that into a config file is we'll start at the bottom one. There's the inline sets. We're basically doing a pattern match and replacing that with the environment variable text in etc.config. And the other one is confd. So confd comes from a couple of the CoreOS folks. And it's a templating engine that uses Go-based templating, and it will basically take key value pairs from a number of different locations, one of which is environment variables, others are like etcd and console and stuff like that. So what this means is if you use confd, it becomes easier later on when you start wanting to use things like service discovery. You already have the tooling in place to do that. You're just simply switching out the confd backend. And so this is an example of our confd template. So we've got a metadata file at the top there, which is saying our example is our template is example.conf. The place we're going to write it to is app.example.conf. Set an owner group, mode, stuff like that. And then we're declaring what keys we want to listen to. And so this basically tells confd to watch any keys that match that or are a subdirectory of that. And if it changes, rewrite the config file, and then it then runs a check command, which you can put in something to just check for syntax and stuff like that, make sure the config file is correct, and then a reload command, which is in case you need to restart your app or do something else to actually make the template take effect. And then you can see in the bottom, that's my actual template. It's a really simple Python template, and it's basically just using the squiggly braces there, the Go templating way to say there's some code in here, and get v is basically going to grab the value of the keys /services example text. So etcd and console, their keys kind of look like a directory structure, which is why it looks like that. When you're doing environment variables, it will actually translate that to be all uppercase services _example underscore text. And so if that environment variable is set, it will take that and it will write that into your config file.
Question.
Yes.
So you were saying that you put things in environment variables so that secrets couldn't get into sort of like things like PIPs and those kinds of weird things that you would factor out and get those would all be accepted with the configuration in the environment variables.
That's right.
Yeah, but how do they get to the environment variables?
Well, so I mean, it depends on how you're actually launching your Docker containers. You might be launching them by hand, which you're just adding them when you do the Docker run. You might be using a PAS like Deis or Flynn or something where you tell it what config values should be using the command line tool, and then it will rebuild and rerun the container based on that. So the fourth factor is backing services. So a backing service is any service that your app consumes over the network, kind of as part of its normal operation. And this is mostly things like databases, stateful disks, stuff like that. And you should make no distinction between a local and a third-party service. As in, like, when your app is wanting to talk to a local MySQL database, it shouldn't have to worry about anything more apart from the fact that it's like got a host name, a port, etc., just like you would with RDS. And so you want to move, if there's any, like, yes, you need to actually run that database if you're running your own database, but you don't want to do it within the context of your app. You want to move it outside of that, and that's handled by a DBA team or it's handled by Chef scripts. It's already handled outside of this. Like, when part of the 12 factor is we're zeroing in on just the application itself.
But that address would be included in what goes in the environment variables and not in the stuff that you would include in the config inside.
Exactly. So any backing service that you're configuring by environment variables. And one of the things that gives you is that if you're running a local database, you're having troubles, and you decide, fuck it, I'll just go to RDS. Whoever's counting just said it. You can basically you can back up your database, restore it to an RDS, stop that container, start a new container, and use the different backing, the different like hostname, password, etc. in your environment variables, and you're running again. So it's very, very little, no configuration change, just a different runtime change to actually completely change out your backing service. And then finally, the hardest part I think of this section is persisting stuff to disk. You don't want to persist anything inside your container because obviously when your container is destroyed or goes away, you lose that data. So you should think of anything that's writable in your container is throwaway. You want to try and avoid having to try and keep it by running Docker commits and stuff like that. So if you're just getting started out and using something like Chef to deploy all of your stuff and then using Chef to deploy your container, you're not really doing any sort of dynamic placement. So it's okay to do like a volume container or a bind mount from the host into the container, something like that. But as you move to a more dynamic nature, you need to figure out how to get your data into somewhere like a central location. So there's Flocker, which is a fairly new thing, which uses ZFS and a bunch of magic to try and move your data around to wherever you're running your container. And then there's old school stuff like running an NFS server or using DRDB or Gluster, or even just having rsync and having it like sync every 5 minutes or something. You don't have to go super crazy with that right now.
Guys from Cluster HQ are at Container Days. They're the ones behind Flocker, and they have a pretty slick website that explains a lot of those things. Your persistence is a factor that's bugging you.
We've actually been using Git to sync some of those workers too.
Yeah, that's not a bad idea. Have the resources in Git and do a Git clone. Have it in S3 and just constantly pinging and pulling down files from S3. There's a ton of ways to handle it. If you have something that's really stringent, like WordPress, where one server's like writing files to a file system all the time and the rest want to read from it, that's when it becomes difficult. But if you're not doing anything that crazy, this may not even be a problem you need to solve.
I noticed you didn't mention block stores in some sort of block service like Ceph.
Yeah, so I mean, if you're going to use a block service like Ceph, you're still mounting it directly to your host. So I don't really see that much difference to just using a volume mount from your host, and it's sort of outside the purview of the container in the app. And that is definitely one way to do it. And I know I've seen all sorts of crazy stuff where if a host dies, a script will run to remount that block device to something else and rerun apps and stuff. So that's definitely a possible way to solve it.
Does Flocker abstract object stores like that, or I'm sorry, not object store, separate blocks people?
I don't know. I haven't done a lot with it, so I just know it exists.
So were you saying that every time you start that container, you want some persistent data to live beyond the container, right? So
Right. If you need to have persistent data,
well,
if you don't, like
it often happens. Like
yeah.
So my question is, what exactly are you saying? You're saying that every time it's just a mount point, or are you saying that it gets actually copied into the container, and then I wasn't.
Well, it's up to you. Like a mount point is easiest if you're pretty sure the host is going to stick around, right? If you're not sure about the host sticking around, the host dies, you lose your mount point as well. So then you need some sort of
unless
shared
you're
file
mounting
system.
NFS to
Right. If you're mounting NFS, that's one way to do it. You don't have to copy around. If you're doing something like rsync, maybe when a container first comes up, it as part of the start script, it does an rsync to pull data locally, and then kicks off another service every 5 minutes, just rsyncing, and that way you're only ever 5 minutes behind. And actually, for something like WordPress, that's probably sufficient because that's usually like images, avatars,
So
and
the
stuff
goal
like
is
that.
caching that data close to the container,
Right.
but maintaining integrity if the container is lost and it's persistent. That's
Exactly.
kind of the goal.
Yeah, exactly. And so configuring backend services, like I kind of said, you configure it via environment variables, pass it through, and it's just showing a template that would be written out by confd, whereas I've got db name, db password, user, host, and stuff. And then when I do the Docker run, you can see I'm just setting those environment variables. So if I had a WordPress container that was set up like this, it would know where to connect to, and it would go to the database and start running. Fifth factor is basically saying that we should have separate build, release, and run stages. The build stage is basically when you're taking your code repo at a specific Git release and you're converting it to an executable bundle. You're doing any builds, you're building any binaries, any assets, you're fetching any dependencies and vendoring them in the right place, that kind of stuff. So that's kind of now you have an immutable image, which is your base application. The release stage is actually doing another Docker build, starting with that image you just built, and it's actually adding your environment variables in there. And the reason for that is now you have the built artifact and your complete like runtime environment all declared and built into like an extra layer on top of that container, and that you version with a release version. And now, and if you're pushing that to a Docker registry, now I can run any version of my app exactly how it was configured, exactly how I want it to be done at any time. So if I'm on 1.3.2, I upgrade to 1.3.3, 10 minutes later I realize there's a bug in it or something, I can just kill it and do a Docker run of my app 1.3.2, and the older version is up and running. Now obviously there's some data persistence issues you have to worry about with SQL schemas and stuff like that, especially with an upgrade. But that's all things you should be thinking about to try and enable, at least a couple of versions back from any given release.
Question.
Yes.
You said release with your environment variables, so there's nothing when the container is stood up, nothing is configured there. I'm thinking like east-west regions, things like that.
Right. So yeah, the idea is when you do the Docker run, which is the run stage, is you want to have like as little configuration in there as possible. Like you even want to be declaring the command you want to run, the port you want to listen to in that release stage. If you're going to be running it in different regions, you might you're probably talking to different databases and stuff like that, so you're going to end up with like completely different release anyway. But that might be a point where you have some slight changes, and it might be worth putting them into the runtime. Because one of the things I kind of feel, especially, so if you're using a PaaS like Deis or Flynn or even something like Cloud Foundry, it actually takes care of all these 3 steps for you, and they're pretty much transparent, and you don't really need to care about it. But when you're doing it yourself, you're either doing it by hand or you're getting Chef to run your Docker commands for you. You kind of do care about these things, but also you need you can probably care a little bit less about the release stage, and you can probably just do the release and run in one go, right? And this is where it comes from. This is the 12-factor way to do it, and then this is the practical way to do it. And so there's absolutely nothing wrong with putting some or all of your config stuff into your environment variables. It's just like if you want to move towards going to a PAS, you want to think more about those 3 steps.
So you said that in the release step is where you want to set your environment variable?
Yes.
But I didn't think you could dynamically, at least on the command line, set environment variables at the order. I thought that was only at runtime.
Well, so basically you're creating a Docker file. Like your build process would create a new Docker file that would start from that and add in your environment variables, your command, any other bits that differ. And that's exactly how like Deus does it. It creates a new Docker file, builds it out, and then pushes it to a registry.
So the difference here is just you're adding another layer with a hard coder for that environment. You call that a package release.
Exactly.
So it's like you have the base layer of Docker, which is the one that allows you to take in the environment variables.
Yep.
You run an instance of that with specific environment variables. You close it in the Docker, you call it a name, and it's like a snapshot.
Yep.
Okay. And the third one, the run, is you building that dynamically. You're starting with the base layer, and then you're creating the passive variables and deploying that final step, right? All in one command.
Right, exactly. Our 6th factor is basically saying processes are kind of the important thing, and your application should be treated as stateless processes, or in this case, stateless containers, which is kind of, we talked about a bit of that. So you want to make sure that you're not saving any state at all, with a few exceptions, to disk by the application, to disk inside the container, that is. But rather should be sent to a backend service. That backend service might be an NFS mount, it might be a MySQL database, or you might be storing session data in like Redis or Memcache or something like that. Your app though can write to disk or local memory for like short-lived transactional like cache and things you don't give a shit about, right? Things that if it just disappears, who cares? But if it's important data, you should not write it in the container. Or if you do, you need to figure out how you get it out safely. And then on that same thing, sticky sessions are something you want to try and avoid. There's a few reasons for that. The main one is, especially like if you do it using like dynamic placement, you kind of fair way down the Docker way of doing things. Containers will come and go when scaling events happen. So you're gonna, like anytime that happens, users will be logged back out, things like that. So you want to try and avoid using sticky sessions in your app. If you do use them, A, you've got to have a load balancer that supports them and can reliably keep sending them to the right place. And then B, you need to live with the consequences where if your container dies, you know, those people lose their session to your app. If you're deploying it if you're running Docker run by hand, you're running chef recipes to do it, you've already decided on your placement. So in cases like that, sticky sessions are less of a problem. But if it's super dynamic, then you can definitely start to see issues with sticky sessions. Seventh factor. It's basically saying that your 12-factor app it should be completely self-contained and doesn't rely on an external web server like Apache. It should be exposing its ports directly. It should be using, if you're Java, like Jetty, or if you're Python, it should be using WSGI or Ruby. You'd be using Passenger, or something that comes with the language to do your web front end bit for you. But because we're running in a container, and the container is our app, we can run whatever the fuck we want. So throw Nginx in there if you're running a PHP, throw Apache in there, like that's cool, because it's outside the container looking in that we're really caring about. And you're not running Apache outside the container, you're running in the container. So now Apache is actually part of your application. You would have declared it and isolated and all that sort of stuff, and you did your Docker build, Docker run. And then obviously port binding, you actually have to expose those ports. So you're either doing it in the Docker file by the expose command, and then if you run Docker run with a $P, it'll just assign random ports to push through to your container. And that's great, again, if you're in a fairly dynamic, about how you place things, you've got a good load balancer that can do service discovery to find out where they're running. Chances are you don't have that, so you're probably going to be doing it with a -p and specifying the port that you're binding through. So you might say my web app is always port 8080 on all of my servers and goes through to the container. And that way, traditional load balancers and stuff don't have to understand service discovery to have a good idea of where to find your app. It also means that because we're doing this port binding, any application can now be a backend service for any other application because it has a known port, it has a known URL. If you're pulling it out of, if you're using service discovery like console, you can actually use like a DNS service record, and it gets really seamless. Our eighth factor is all about scalability, and scaling out rather than scaling up. So you want to take, if you've got a fairly large app that does a lot of things, you want to see if you can break that up into multiple containers when you run it. And maybe you're running one container to do your web requests, maybe you're running another container to take images and convert them to thumbnails and put them up into S3, and then that kind of starts laying the groundwork to be able to run them on different machines and scaling across rather than scaling out. Because you're like a VM or a physical box, obviously it can only go so tall, whereas your VMs, you can buy as many as your credit card will let you go, so you can scale out very, very quickly. And then the other thing that they talk about in this factor is that really processes are your first class citizen, and you want to run them in the foreground. You want to try and avoid daemonizing. Like when you run Apache normally, it just automatically goes to the background. With Docker and 12-factor stuff, you want to pull it back to the foreground and run everything in the foreground. Otherwise, you've then got to have another script that checks that it's actually running, reports the PID, pings it, making sure it's still running and stuff. Whereas it's in the foreground, when it dies, and you know that it's dead. And stuff like Apache, Nginx, most apps have a way to run in the foreground. You just have to kind of figure out what the options are and what the flags are.
So Docker's website has a decent list of some of those with all the arguments that you need to put in. Some of the run examples.
And what you're saying the benefit there is if you're running that and it dies in the actual container, and then you can
exactly.
monitor it versus if it dies in the background.
Exactly.
Something's holding
Like
that.
I've seen people will like run Apache and then will tail the Apache log to kind of the tail becomes their long running command. If Apache dies, the log doesn't go away.
Right.
So that container thinks it's running and thinks it's healthy. And so obviously you're going to run into problems and stuff like that.
And you don't want to heal the container, you just want to delete it, start a new one.
That's right. Although, if you're running in a tool like Runit or something like that, you can say, hey, if it dies, restart it and see what happens. If it dies again, okay, maybe we'll just let it stay dead and let the container clean itself up. Another factor is about disposability and basically saying like startup should be super fast and shutdown should be as graceful as possible. Docker helps us with this fast startup. Even when you're using conf to write a bunch of templates, if your container takes more than a second or two, you probably need to try and optimize it a bit more, make sure that there's more things in your Docker file setting up like any requirements and stuff like that could take a while to run. So that when you actually do the run, it's like super quick. And then when a container gets a sig term, it passes that to, or a kill command, it passes that to the app, to the PID1 of whatever's running inside of it. And so you need that to respect the kill command, and also know how to pass that on to its children, and then also wait until its children have shut themselves down before it shuts down itself. And it helps avoid zombie processes and stuff like that. For short-living apps, for like dev test environments, you don't really need to care about zombie processes, but if you're running a lot of containers on hosts that are around for a long time, it could potentially start to cause problems. And also, like, as far as sudden death goes, like, there's a lot of stuff about, well, you should design for failure, or you should, like, if you shut down, like, put messages back in a rabbit queue, clean up, stuff like that. But most of this stuff is going to be web apps, and, like, if you lose the occasional web connection, like, who gives a shit? They can just hit refresh, or that whatever is hitting your API can retry. It's not that big a deal, like 1% of 1% of 1% of connections. Like, don't lose too much sleep over it. 10 is really easy. We're already most of the way there, right? It's making sure dev, stage, prod are all as similar as possible. And a few things, if you're running RDS, view database in production, just run a local MySQL container or local MySQL database to do your dev work. as long as at some point before you actually deploy to production, you're testing against a real RDS database to just check for any small discrepancies, you can really think like local MySQL is roughly the same as managed MySQL. Local Redis is roughly the same as managed Redis. So don't worry too much about that as long as you catch it further down the testing pipeline. And Docker Compose is a really good way to like tie together a bunch of an app with a bunch of backing services. So you want a Redis server and a MySQL server in containers. It'll spin those up super quick for testing. I prefer to do it in Vagrant. I usually use CoreOS, and I use the Cloud Init stuff to kick off the systemd units to start those things for me. But if you're already doing config management like Chef, you probably already have that tooling to just launch your backing database, to launch your backing Redis server. So you kind of just use Vagrant up to get that running, and it's pretty straightforward. The 11th one is logs, and this is back to you don't want to be writing data in your container. You want to always write anything running in the container should write to standard out and standard error of the container itself. So it gets fed through the Docker log subsystem, and it can be then accessed via other tools as like a log stream. If you're writing log files in the container, then you have to do log file management in the container, right? Otherwise, you run the risk of your container slowly growing, and taking up all the space that you have in valid Docker, or all the space you have because you've got everything mounted in Slash. So now so if you're actually writing logs there, maybe you want to do like a bind mount or a Docker volume to try and get the logs out of the container. Maybe you're going to have to run syslog in there and write to syslog instead and have to syslog ship it out. So depending on what your app is, there's different ways of handling it. If you can specify the log file location, you can use dev standout or dev standard error, and that will actually redirect it to the actual standard out standard error of the application. So that works great for Nginx, Apache, stuff like that. But some other things aren't that friendly. So MySQL, for example, if you don't put a file extension in for its error file, it will just add .err to it. So it'll try and log to dev standard error, and of course that's not going to work. So in that case, you can do like a symlink of dev standard error to varlog MySQL.error, and that works as well. And then by writing to standard out, we get to use tools like Logspout and the new logging drivers that are going to come out with Docker 1.6 to actually then ship our logs around. You can use, if you're using CoreOS, you can use journal cattle to view the logs of the container. So it really opens it up to really easy ways to ship logs around. If you're using Logspout, you can tell it to log to a syslog server. You use something like Papertrail, and like within seconds you've got all your containers logged into a central location that is basically a backing service because it's out on a SaaS somewhere, and you can just start looking at your logs. And Boyd actually has a really good blog post on how to do that, how to hook it up to Papertrail if you're interested in doing that. And the other thing is, if you have no other choice, set a self-destruct timer. Say every 24 hours, kill the container, start a new one. As long as you don't care about the contents of the logs, it's better than your server filling up, right?
Quick question on logging. So if you have multiple processes running on that, obviously there could be different log files. Is the recommendation still funnel it all to a single and then figure out how to parse it out?
Yeah, say you're running supervisor D or run it, and if you're running it in the foreground, it's going to push its standard out to you. And then most of them have a way to run whatever it's running, pull to it all the way through to its standard error. So everything is
standard error is going to have a large part of many logs, not
Oh, yeah.
from a single application.
Yeah,
So
yeah,
you're saying you funnel it and stream it all, and then on the other side you figure out how to
Yeah, exactly. And the other side, maybe
figure
you're
out how to
running
make sense of it.
you're running Splunk or you're running Logstash or something, and you can run filters and start making sense of it. You're logging things like container IDs and things like
Like
that.
a logging
so,
bus, kind of everything goes
Yep.
in there, and then you parse it.
So yeah, 12 factor, we're kind of nearly done with our factors. So this is about one-off processes, management processes, stuff like that, management tasks, I should say. And a good perfect example of this is a DB migrate. You don't want to like SSH into a container and run a DB migrate when you're doing an upgrade. So you want to instead either create a new container just for the purpose of doing the DB migrate, in which case you would actually just launch the version of the container, the version of your app that you want to migrate to, and run the DB migrate in there, and then launch your actual application once that's finished, because it's a process running in the foreground in Docker, so when that DB migrate finishes, it'll shut itself down. Then you run your new version of your app, you do some testing, you shut down the old version of your app, flip the load balancer across, and you're going. You can do a Docker exec to get into the bash, like an existing container, but that's kind of, you don't then push the standard out because you're working in an interactive shell. Whereas if you're doing it with a task running from Docker, you're getting it through standard out, so you're going to get it through logs. So you're going to see it show up in like Logstash or Splunk or whatever that you've done a DB migrate. So it's better for debugging that later. So you can use Docker exec, and sometimes it's useful to run Docker exec to get into running container, actually do some debugging. But for the most part, try and avoid it. But it's definitely better than running an SSH daemon and SSH into containers. So I'm going to do some demo here. So I'm going to see if...
Just gotta get in there for a second.
Okay. Oh, you're on there.
Yeah.
There's still some chips and salsa in Carnegie if anybody
So I'm going to see if I can angle this so I can talk and type at the same time. Just going to mirror my display and see how terrible it is. It's not too bad.
telling you, Paul, you gotta warn people when you put that screen up.
Oh. How's that for font size and stuff? Is it readable? Probably not. Alright, okay. So I'm working with a buddy of mine. He's got this idea for a startup. It's called Scouter Park, and it's basically Yelp for public parks and recreation facilities, mostly aimed at like mothers with kids that want to find local parks, tourists and stuff like that. And he's not a developer. He's a project manager, and so he decided to do it in PHP so he can get so he can get cheap offshore developers to help him put together his MVP. And because it's in PHP, I was like, okay, that's probably a good candidate for like putting through this kind of Factorish mindset. And so so basically, I've set it up with using Docker Compose. So it's got a web server and it's got a database. Let me see if I can bring up. Is that readable? Mostly. Alright, so this is the Docker file I put together for it. And you see I'm including a lot of crap. The things to really notice are HHVM and Nginx for running the PHP stuff. I'm also installing etcd, and I'm also installing confd, so I can do templating. And then that's kind of the important stuff out of the Docker file. And then my command to run is scatterpath docker bin root. So if I look at that, this is the script that runs. So I'm grabbing a bunch of environment variables. These are just some housekeeping stuff. These are the environment variables we're passing in. And so I'm passing in short name environment variables, and I'm renaming them to match the keys that I'm going to be looking at with confd. I'm setting up some MySQL options so I can do a migrate, pull in the .SQL file if I need to. And then if I tell it to use etcd, which I do via environment variable, it will connect to etcd and pull its configs from there. If not, it will do it via the environment variable backend, and then it will actually run confd, and it will keep running confd until confd says it's successfully written its templates out. And the reason for that is if you're doing service discovery, you don't know that everything is up and running when you launch this container. and so it'll get errors back. So this just keeps looping until all its backing services up and CFCD and because I'm using environment variables here, they'll just run once and then move on. Once that happens, I actually wait for MySQL to respond, so I'm just doing a show status with the MySQL options I set for the environment variables earlier. And then I check to see if it has a table, a specific table. If it doesn't, I'm going to assume that it needs to have the database imported, so that then imports the database. And then it finally runs supervisor D, because I'm running that with exec. Supervisor D will take over the PID of the script, so supervisor D will be PID 1. And at the end of that, after that, I then wait. So if it gets a kill command, it will wait until supervisor D successfully shuts down before it exits itself. One other thing it runs, so let's look at, I have a template for supervisor D. And so again, if etcd is set, it'll actually run confd in basically long running mode, so it'll just keep polling itself. So it basically runs like a daemon. I'm running a health check script, and I'm running nginx and hhvm, all of those things in the foreground. So what the health check script does is, because I don't want to check for like nginx and hhvm and a bunch of other stuff, make sure they're all running. So I know nginx is always going to listen on port 8080. So basically I'm doing a netstat of port 8080. And if it's listening, then I just keep looping. If it ever stops listening, this while loop will exit, and I'll go to a kill 1, and that will kill my PID 1, which is supervisor D, which will then actually start shutting everything down and kill itself.
Where was that call from?
So that's in my Docker file. That's my command right there. So anytime if I run this Docker, if I run the image created by this Docker file without any arguments, it's going to run that command.
So this is, I mean, you went over the 12 factor things, but this doesn't quite follow it, right? Because you have a supervisor D in a container managing processes, right?
Right. As I maybe I wasn't
synchronizing.
Right. So maybe I wasn't super clear. I did have some notes to talk about it, but maybe I didn't quite cover it. It's actually like when you're talking about the app being a container, the container being your app, it gives you a bit more freedom to do things like that. So it's actually okay to run supervisor D or to run it or something, as long as you're running it in the foreground and you do request for shutdowns and stuff like that, and you do the health checks to make sure everything in the container is running. It's definitely okay. So I must have missed my notes for talking about that.
So where are the health checks in book?
So that was this health check script. So this health check script is run, and it just loops over this netstat and checks that nginx is listening on 8080.
So who triggers this script? Where is
This script runs in the container.
What calls it?
where
What
is it?
starts it?
Yeah.
So supervisor starts it. So there's three processes that supervisor starts. It's the health script, nginx, and hhvm. So with the nginx config then, I don't think I have any of this templated, but what I have is you can see my error log. I've set to dev standard error, and my access log is to dev standard out. The rest is all pretty standard nginx stuff. This is how nginx talks to hhvm to process the PHP stuff. But if I actually look at one of my config files that I'm writing, you can see I've got the confd get n/db/host, and so that's going to pull the service discovery bits out and actually know what to configure to.
So Paul, in some ways, this is kind of separate of Docker, right? This is your provisioning of that container.
Yeah, this is the content of the
Docker
container.
just says, call this boot thing,
Exactly.
do its business, and when you're done, tell me, right? So this could be, in this case, shell, but it could be anything else, right?
Yeah, absolutely. Yeah. So this is mostly all written in Bash, and then calling like confd to do the templating and stuff like that. But it could be absolutely
Any
anything.
provisioning tool you want.
Yep. And then so I think I can actually just do the demo.
So are your backend services other containers as well in this example?
Yeah. So in the example, I've got a container because this is kind of the example is showing the dev environment. I actually have a full set of chef cookbooks, which for deployment to production, which right now aren't using the containers, but will start to use the containers. And so that way, in dev, I want to move away from using Docker Compose and just use Vagrant. And it's run the chef cookbooks to deploy both the backing services and the application itself.
Can you elaborate on that point you made earlier? You said that Docker Compose was actually moving you further away from having, your dev environment to be the same as your prod environment. Why is that?
Well, so my prod environment, for now and for a while, will be machines running in the cloud that are configured by Chef. So if I have my dev environment, just a bunch of Docker machines that spin up, then it's not using the same set of tooling. So it's not testing my deploy scripts every time a developer spins up a dev environment. Whereas if I make them use Vagrant and do the chefs, it takes a little bit longer to run, but they've fully tested my deployment tech tooling now. So as we progress, and if we get to the point where we're fully Dockerized and we don't need any chef cookbooks because we're using RDS for our database and stuff like that, then I can probably start thinking about going back to use Docker Compose or doing our dev environment like straight on a PaaS like Heroku or Deis or something like that, and just skip this whole local dev environment blitz. Yes.
Right. So this is all under the assumption that you have a production environment that is not Dockerized. That's why you're still using the Chef cookbooks. You just said that the Chef cookbooks configure those systems.
Correct. Right,
Okay.
but the chef cookbooks will
This would be significantly more streamlined if you actually ran
exactly.
Docker. in
Right. If
production.
you were all Docker all the way and you were using RDS and other
Right.
things for
Your
your
pain
feeding,
would
right.
a lot of this
pain would go away.
yeah.
Yeah.
Well, in terms of the pain that you were just talking about, why do you have Nginx buried in the same container as HHVM when there are components out there like JWild's Nginx proxy that was basically do all that work for you? What was
Because
your decision?
HHVM isn't actually, it's basically just a PHP like rendering tool like PHP FPM. It's not a web hosting tool, so you still need like Nginx to talk to it. I could potentially run it outside still and just talk to that HHVM socket, but I haven't really played with that yet, so I'm kind of just like.
And part of the point of your talk is this is your comfort zone.
Exactly.
Us, right? Okay.
Exactly. And so I built this out exactly what Boyd said to suit my comfort zone and also the people who I'm working with comfort zone. If it was just me, I'd probably just be straight Docker or everything. But it's not just me, and I have outsourced developers in foreign countries that we have a hard time communicating at the best of times. So to introduce a lot of new things to them they don't understand. I mean, even just talking people through using Vagrant can be a massive jump in their minds. So going down the whole Docker way explodes some heads.
And the reason you're running Nginx in the same container as your PHP is just for simplicity?
Correct. So I mean, I need something in the container to do the PHP rendering because HHVM, I think Nginx talks to HHVM over a port, like port 9000 or something. I might be able to run it outside the container or in a separate container, but it was easier for me to set it up this way. And now I've got one problem. I've got one container to manage rather than two containers to manage.
Sure.
I was actually just doing this today, interestingly, with PHP. And the thing I run into with Nginx and PHP is static resources. Nginx goes for static resources.
Right.
So I want those resources available. What I end up with PHP, whether I'm running FPM or HHVM or whatever, I then have to mount my application into both containers. For the static resources in Nginx and the PHP resources in my PHP rendering. With something like Django, this is different because with Django I actually render my static resources over here and I can mount that directly to Nginx and then have it talk to my pipeline. But for PHP it actually makes more sense.
Okay.
It's just a artifact.
So for Django, that's only true if you run. I can't remember. It's
Collect static.
yeah, thank you. Collect static. I'm almost certain there's got to be a correlate because Django's a framework, whereas PHP's a language. So I'm sure like Laravel or something in PHP.
I'm not very familiar with Laravel. I
Okay.
use Cake and Drupal and
And these
neither
don't
of
have
those
a
play
collect static
well.
correlate.
Say what?
And they don't have a collect static correlate.
Not really.
Okay, so I mean that's kind of cool too. Then in terms of the talk, because then you've got certain languages that just don't that almost dictate what you need to do exactly.
Yeah.
what it is.
Yeah.
Both Cake and Drupal exist within the web. And you can't pull the I don't know about Laravel, but I know about Plate and Drupal, and neither of them you can roll out. Django, you can separate the static from the dynamic real time.
Yeah.
Thanks.
But didn't you say as part of the Bell Factor recommendations that you didn't want to run the Nginx as a separate container, right? I mean, I thought that was one of the bullet points. Because that's
Well, it becomes part of the app.
Right.
Right, yeah, and that's
what you
so
did.
that's what I got. I made
So
it
that's-
part of my app, but you absolutely could turn it into two apps. One app being the proxy and static web,
Yeah,
which is
the other
Nginx,
app.
and one app being PHP, which is a backing service for that other app.
Right.
So I think that would still fit perfectly within the.
Then you
the
just
way.
have to do the compose to make sure both are right.
Exactly. So I'm going to run the Docker Compose. I ran it, but we were talking, so we kind of missed it.
I would say the people on
Retail and non-offers.
offers.
Yeah,
Offers
offers.
here, they run PHP, they also run Untitled Chapter.
Yep. So we run Docker Compose up. I've already built it just in case the network was slow and stuff, so it's pretty quick. So it's already up and running. You can see up here, it did start up MySQL. It did the database migrate somewhere, and it ran confd to render all my templates. It did my database commands, and it ran. So that was in like a second. So in theory, if I go to a web browser, where's my Firefox? And so this is now the contents of my container. So it renders out the page. That's that thing at the bottom is pulling from the database, and I can actually say in the postcode, zip code, and hit search, and it's talking through the database. It's searching. So that's kind of the app all inside the container.
That's awesome. Just so your host is already a Linux host, and therefore you're just running Docker directly right now?
Yeah, that's right. I run Linux on my laptop,
Okay,
so
so
I don't have to worry
you
about
don't
using
need to
Docker or
do
any of that
Docker
stuff.
stuff.
But what I can show you next.
But if you're using Vagrant, then you will create a separate.
Exactly. So the next thing I want to show you is actually using, so that was, I've taken a part of Factorish and used it for this. I want to show you actually Factorish itself. And I ship a little example app with it. So let me bring that up. So this is Factorish itself. I've got an example app, which is just called example. And again, it's starting from Python 2. And I see I'm setting my workdir and command and expose up here. That's just, they're never changing, so I put them at the top so they never get invalidated and have to run again if like I change with an add or something. So that's just a little bit of speed up when I do Docker builds to do that. I'm doing all my base dependencies. I've got a bunch of system dependencies I bring in. That's because I don't really care that much about running a fat container. I'm already running like 500 meg of them too. I might as well run another 100 meg of like wget and curl and vim. So if I ever need to jump in, especially in this early stages of development, I can do that. So then installing confd and etcd here and setting them up for run. You see I'm doing a run and then I'm like chaining all these commands together. And this is mostly so I can control the layers and what goes into what layer. So if I'm running building multiple containers, I can use the same set of commands or create another base image that I can build from later. Just so I share more layers so my build times stay pretty fast whenever I have to do a Docker build. And then finally I'm adding my code in, and I'm doing making sure I have a user that's not root to run, and I'm doing a pip install to make sure I've got all my dependencies.
The difference here is you have a lot less provisioning than outside of Docker.
Exactly.
Everything is done pretty much in Docker, right?
Well, this is still, so I'm still calling an app bin boot, because I still, if I want to run confd, because I'm talking to etcd, I still want to run a couple of processes. So I'm still running a bin boot.
So that's just a hook, so you can then expand that bin boot.
Right,
and do
exactly.
more things.
Yeah.
Did you create a user there?
I did.
Why do you bother with changing from root in a container?
It's supposed to be a better practice. I don't know if in practice it really buys you any extra security, but I mean it's 2 lines of code, so you might as well.
Okay.
So again, I have a little bit of housekeeping just to set some defaults, ports and publishers and stuff. That's not important right now. I'm doing the same etcd config I did. So a lot of this stuff I'm just copying and pasting from one repo to another as I use it, and then just changing the bits I need. And then I'm actually using runit now, so I have some extra bits here to handle pulling runit configs out. But the same thing, I run confd over and over again until it successfully renders, and then I'm running appbin myinit. So myinit was done by the guy who did the Fusion base images, and they did a really good blog post on zombie processes and how to avoid them, and they wrote this PHP init tool called myinit. So I'll borrow that just to try and keep my processes and stuff clean. And then that actually, it runs through and it calls runit. And what runit does is it looks in a directory that's filled out by templates. So I've got three files that are put into its the service run. One is to run confd. You can see runit services are actually just basically a shell script, a bash script of some sort that tells them what to do. So this is simply running confd, running my actual example app, which you can see it's changing the user to app, and then it's running unicorn. And then my similar health check is what I had before to check for health. And then my actual app, my example, let's see, where am I? My example config is here. And so this is one I showed in the slides earlier. Really simple config file. It's just pulling that out of confd, which is getting it from environment variables or from etcd. And because I'm running unicorn in the foreground, it already logs the standard out, standard error through runit and should come up to the front. And then some interesting stuff that Factorish brings. So I have a factorish.yaml file, and that allows you to describe it basically tells Vagrant what to do without writing a bunch of bullshit Ruby. So I'm basically saying I want X amount of memory and X amount of CPU in each instance. I want 3 instances. I want to expose some ports. This is the CoreOS version I want to run, or the minimum CoreOS version. And I'm using Flannel in this. So Flannel is a CoreOS tool that gives every Docker instance, every Docker container its own IP address, and then does the wiring up of the networks between the VMs. So each VM will get a /24 out of this network range. And then I have applications described. So I'm actually running 3 applications, which are basically Docker instances that are going to run in each CoreOS VM. One is a registry, and I'm mapping in a host volume from the VM. I'm actually mapping in a host volume from my laptop to that. So anything I write to the registry ends up getting saved on my laptop. So if I destroy this environment and restart it, I still have all of that stuff in my local registry, so I don't have to keep going out to the internet to grab things. And that gives me a huge speed up. And I actually also save the registry tarball. I do a Docker save of it into a local directory as well, so I don't even have to go and fetch the registry. The next thing I do is I grab Registrator, and what that is, it talks to etcd, and any containers that are running that has listing ports, it puts in key value pairs in etcd saying what the container is and what ports are listening to. So I can actually do service discovery lookups based on that detail. So I don't necessarily need my app inside the container to go and figure out to talk to etcd, because it can talk. It doesn't need to talk to etcd. Whatever's running it can and figure it out, and that's pretty useful as well. And then finally, I'm running my actual app here, and big difference here. I have a Docker file specified, and so that means it'll actually build that if the image doesn't exist, where the other ones doesn't have a Docker file, so it knows to just go and fetch it.
So this YAML is similar to the Docker Compose YAML, but the syntax is
Right. So this is actually read into. So I have a Vagrant file, which stands up, which it requires a Factorish Ruby file, and that reads in that YAML file and figures out what needs to be done and then does a bunch of work. And then Vagrant then uses variables from that to figure out how many VMs to run and stuff like that. It also templates out the cloud config file. So I've got a user data file that's an ERB, and you can see I've got a, like if flannel is enabled, it's going to print out some stuff. If not, it won't. Then I come down to the application declarations. It's going to loop through all my applications and create a systemd unit for each one, so that like I don't have to worry about starting services and stuff. It figures out what needs to be run. And then it also goes through and sets up a bunch of aliases for like kill underscore example, kill underscore registrator, kill underscore registry, and a bunch of things. So I can actually do really easy like start-stop rebuilds of images without having to run the full Docker commands. It's all sort of pushed into a bunch of scripts down here.
How much of this is baked into Vagrant? How much is you write?
So almost all of this is stuff that I wrote for the kind of the Factorish stuff. And the idea is you don't have to really care about that. All you have to care about is this YAML file and your code itself, and it kind of figures out the rest. So what I'm going to do is find in my README somewhere I have instructions.
Just out of curiosity, as you're building this or as we get into this, what's the best way to debug when things don't work? I mean, there's a lot of moving parts. Would you agree?
Yeah, there are a lot of moving parts.
So how do you debug?
You kind of just have to figure your way through it until you understand how the different moving parts work. So obviously you have to know how to debug CoreOS, which means you need to know how to debug systemd, which means you need to understand like how the new systemctl, journalctl, and that sort of stuff works. Then you need to understand Docker, and you need to debug Docker.
There's all these layers.
And, yeah, there's a bunch of layers. It's painful at first, but once you've dealt with it a little bit, it's not too bad. And because we're doing a lot of stuff like getting all the logs pushed through the Docker logs, and if we're running logspout, we get all our logs to a local place. You don't have to go all the way into a layer to look at like log files, look for errors and stuff like that. I can just run, I have an alias for logs underscore example for when my example app is running, and it will just like start tailing the logs for that from CoreOS.
I'm just curious, maintenance-wise, you walk out, someone walks in, knows Docker, kind of similar background.
Right.
Is this fairly easy to get in and take over, or because it's a little bit custom, requires some hand-holding?
Yeah, so I mean it would definitely require some hand holding, and this is like a sandbox for like me thinking things through and working out how they would work. I wouldn't necessarily run this in production like this. And also, once I've built my images, a lot of this stuff goes away, and I can just do a Docker run on my servers, or I can even mostly I can push to something like Deis, because Deis supports giving it a Docker container, and it will actually take care of being able to pass in environment variables. It reads the Docker logs, it does a bunch of that sort of stuff. So this is just giving me the development environment so I can start figuring out how to make the legacy apps kind of behave in a way that stuff like Deis will be able to run it.
Yeah, you can see you already developed kind of your own patterns, but I've noticed you already kind of.
Yep.
So be curious as people use it, what are some of the best practices emerging?
Yeah, and I don't even really expect anyone to use it other than myself, because this was mostly, as I said earlier, this is mostly me trying to figure out like how I think of how I would want to run applications if they're not really built to run inside a Docker container. And so it's mostly been a learning exercise for me, and if I'm writing some code to figure it out, well, I might as well share it, and maybe it'll help someone else. But it was surprising how quickly it got quite complicated.
Yeah.
But the good thing is when you're actually using it, it's pretty simple. And so I'm going to run, so my example app, just to see it running, I'm just going to run it so I've already built it because like you've all seen how to do a Docker build, and it takes time, so I don't really care about showing you that. But if I run, I'm still running the other one. Alright, so if I run the app, see that was pretty quick, and you can see it says, it's starting at the example without FTD support, so it's already didn't pass through an etcd host environment variable, so I had to switch back to environment variables. Because I didn't set an environment variable for the config, it used the default and wrote that out. And so if I do a curl localhost 8080, it just responds back with root, I'm your father. So if I now run it and set a config value by the environment variable, I'm running the exact same command, just adding a dash E to it, and I apparently fail at copying and pasting. So exactly the same, just with the dash E services example text. And I set that to equal mother. So if I do a curl now, I'll stop clicking buttons. So it's obviously read the config file, it's seen the environment variable, and I set the config file appropriately. I can do a docker es, I can do a docker exec, and jump inside this if we want. And so I have an example. I have an example.conf, and you can see it's written out text mother. If I look at templates, example.conf. So that's the that's what config read from to figure it out. And that's pretty much all that's exciting there. So now I have already run Vagrant up. So to me the more interesting things is when you start figuring out how you can use things like service discovery to set config variables or see what else is running. So if I go into let's go core 01. This helps if I know how to Vagrant. So I've got 3 core OS boxes running, and they're running as a cluster. So they're running etcd. They discovered each other. That's all done by running Vagrant up. There's not a lot of manual steps there. There's no manual steps to running Vagrant up. So now if I run, let's run the fleet command, make sure all my machines are still visible. So fleet is basically used for orchestrating and scheduling running containers. I'm not using that right now, but it's a good way to check to see if all the machines are up and visible, so it sees all 3 of them. The IP it sees the same because Vagrant has that F0 that's always that same IP, but they're all talking to each other. So if I run a etc cattle ls and do recursive, so this is basically anything in etcd is going to print out. So I have a bunch of core OS stuff that is core OS magic I don't care about. That's the flannel stuff I was talking about, deciding which subnet will belong to which machine. But down here is the interesting stuff. So here I have some stuff that Factorish uses to work out if it should build or if it should fetch from the registry. If it doesn't exist in the registry, the first container that grabs like Factorish builds building will do the build and then put it up the registry, and the rest will go and grab it. Just so you don't have like all your VMs trying to do the build at the same time and just burn CPU for no reason. But the /services, so these things are written by no, they're written by Registrator. So I have, let's look at what I've got. I've got Registrator running, I've got the registry running, and I've got my example app running. So both the registry and my example app are exposing ports. As you can see, there's a port being exposed, port being exposed there.
Make the window wider.
Oh, I'm sorry.
You have 1 registry per host or no?
Yes, so I have 1 registry per host, but because they're sharing the file system back, they're essentially the same. And what that actually means is I don't have to set up the insecure registry flags because they're always just talking to local host.
Right.
And that simplifies things a bit.
So did you say Registrator just scans and imports and then reports that back?
So Registrator looks at the Docker the Docker API, and it says what containers are running and what ports are exposed. And it takes that and then fills out the information in etcd. And it runs you tell it how often you want it to run. So that like any container goes away, within like 5 seconds it will get pulled back out of etcd and stuff like that.
And then you just wrote something that makes your port service associations.
Right. And so what I also have is I have this services example text, and that was the config value that I'm setting. And so if I do actually let me do, so there's my example app. And if I do, then I think my CoreOS boxes have split because my network dropped earlier. So it should actually be showing 3 for each of those. I just realized. So I don't know if this demo is going to be perfect now that they're split, but we'll try through it. And then I have got this services example text. And so if I run,
Can you tell us again? So what's the difference now? Obviously, you have Vagrant on it. Generates the three. How did Docker got pushed in there? Containers.
Part of Factorish is it writes down the user data to tell it what containers to run and how to run them. So if we go back to the YAML file, if I go back to this, back to the YAML file here. So everything that's described in this application is basically told to run, and that's done in the user data in this section here, writing out system D units. And so in each VM, there's going to be a system D unit for each of these apps. And there's also, I can run so I also wrote out a bunch of aliases, so I can do logs, for example. And that'll just attach the Docker logs for that. I can also run I can run kill example, it will kill it. I can run build example, it will build it.
I'm just curious, like if you're starting from scratch, you do Vagrant or first you got to build your, like so you do the Vagrant up, right?
Right.
That will generate the VM.
That will generate the VMs.
And run your provisioning.
And it will run the provisioning, and so all of this stuff gets set up by.
So the trigger is Vagrant now.
Yes. That's right.
It took me about 6 hours to pull it all apart to figure out how it works. The brain's bigger than that.
So if I go back, let's see cattle get set as example of text. So you can see this is where I'm passing through a config file. Because one of the things in my here. Wow, this is terrible. I need to figure out how to zoom on this thing. Yeah, because this is my example services text, and I'm passing in this etcd host, which is now actually calling all the etcd bits to use etcd rather than environment variables. So now the app is completely hooked up to service discovery to get its config variables. Right now it's just a text field, but if I had backing services, it would also point me to where its database lives and stuff like that. And my app doesn't need to know about that service discovery because confd takes care of it for me. So there's a bunch of work I don't need to do refactoring my app. I get it for free from a tiny little container that someone else wrote. Yeah, so I've got this etcd host set, and that's set to CoreOS private IP, which is an environment variable that you get on CoreOS boxes automatically. And so it automatically knows how to talk back to its etcd. And so what I'm going to do is a curl localhost 8080, make sure it's working. So that's right. That's using the right values. So if I go ahead and set it to something else. So now it's changed the etcd to have the value of bacon, and then in theory I do a curl against my app and it sees bacon. So confd has seen the key change, it's rewritten the config file, and it's done a restart of the example app, which picked up the example change and ran it. It takes about a second, but most of that is because I have sleeps and stuff in there, so it's not just constantly polling like crazy. So it is pretty quick to happen. I mean, it was like 3 seconds between me doing it and it came through. And this is kind of a very simple example app, but I wanted to really show how how far you could take it. And I showed this off at Container Days, but I don't see too many people spaces who are at that. So basically what I did is I built out the elk stack, so Elasticsearch, Logstash, Kibana, which Elasticsearch is a very stateful app, and so I do volume mounts, and they're all self-configured via etcd, so they'll discover each other and start talking to each other, and it will start up and run. I didn't have enough time to actually start this up, so I you had some technical issues to start. But if you're interested in that, I can show it to you, or you can go and grab it. I've got links up in the presentation, which I'll send out a link to, and instructions how to run it. And the other thing I have with that is I have, so I mentioned Fleet earlier being scheduler for scheduling containers. So it basically will run your container on whatever machine, whatever Core OS machine that's in the cluster has free resources. It will say, you ask for 2 of these, I'll run it on this one and that one. So I don't have to say which one to run it on. And so these are basically they're basically system D units with a little bit of extra metadata for Fleet. You can see, so this guy here is going to run C-Advisor, which is Google's statistics monitoring stuff that will actually watch containers and watch CPU usage and stuff. And that global equals true means it's going to run on every single machine in the cluster. So any machine I start up in the cluster will run that. And I have the same for Logspout, which is our log collection and redirection, and then the same for Registrator as well. And so that gives me my service discovery. So, and then I have Logspout is set up to write to the port it knows that Logstash is going to be listening on. So as soon as I start this up, Logstash actually starts collecting and recording to Elasticsearch any logs that are written to CoreOS by any of the Docker containers. So it actually generates its own logs and stuff as it goes, which is kind of cool. And then finally, so I've got Elasticsearch data container and Elasticsearch container. And so I have, see it's got the add in there. That allows me to specify the number that I want to run when I run the fleet command. And then it uses this %i is a variable that will get turned into the number that's run. So if I run 3, you'll get a 1, a 2, and a 3. And I can use that to tie that into its name, so then I can then tie it into a specific Elasticsearch container that I want to use it as volume. And then I've said here that it conflicts with anything with the same name. So this means that you will only ever get one Elasticsearch data volume on a given host. It won't try and schedule 2 on the same host. So it's kind of some anti-affinity stuff. And then on the actual Elasticsearch one, same sort of thing. I'm saying up here that it has to run after I've already run Elasticsearch data with the same number. So that means that it won't run until the data volume is ready to be written to. And then it runs it, and it uses the volumes from Elasticsearch data with the %i. So it'll always, like, Elasticsearch 1 will always read from Elasticsearch data 1, and so forth. And then my fleet services, I've said it conflicts with anything with the same name, but it has to be on the same machine as the Elasticsearch data with the same number. So that way, the two will figure out where they should run together, and we'll be able to tie up to each other. And then I run similar stuff with Kibana and Logstash. And so you can take those and take my containers and go and run them on your own fleet cluster, and you don't have to care about any of the Factorish stuff, because it's all kind of just magically taken care of as long as you run these fleet commands. So it takes what's a fairly complicated build system and a lot of configuration, a lot of trial and error to get these things running, to now anyone can go and run them. And then as long as they know how to run and operate Docker containers, they know how to get logs, they know how to troubleshoot them, they don't need to worry so much about all the internals of the system. And I think that is about all I want to talk about, and I've lost my presentation. I've got a bunch of links and stuff that I will share, and I'll share a link to the presentation itself. It's got links to all this stuff. And that is it. And questions, yes.
So Factorish is really like a set of plumbing that you created, right, to help you quickly then put your own apps and use that same plumbing.
Exactly. So I kind of came up. So I actually started working on Factorish first, but didn't really call it Factorish. I was like, fuck it, I want to run Percona in containers and have it like auto replicate. And so I figured that out. And then I was like, oh, I want to do something else now. And I basically did the same thing again. And I did the same thing again. I'm like, I should build some tooling so I don't have to just keep like.
Right. So that's what Factorish is.
And so that's what Factorish became.
Plumbing
and then as I figured out a lot of this stuff, like how to get everything to log to the right place, I started saying, hey, this is very much like the 12factor.net. I wonder if there's facsimiles across the board to, I can map up, and that's kind of what I came up with. I do have a blog post that goes into the factor versus backdoor thing a little bit more, and probably goes into more detail than I went through tonight, and that's linked to in the presentation as well.
Yeah.
So there's plenty more to read up on
Great.
if you're interested.
So the problem I was struggling with is where to put secrets. So like if I have a container that needs a SSL cert key,
Yep.
what ideas? Like I'm thinking like different volume from a different registry that gets mounted on this container.
Right. So what I would do in this situation, because if I'm using etcd, I would have a way to put my secrets into etcd, and then use confd to write those into config files in the containers. And that way, as long as my etcd as long as I trust who accesses my etcd, then I'm kind of okay. Same with do it with environment variables. So maybe have config management write down like a etc environment file, and then you source that in before you run your Docker run, and then push the values through. That's another way to do it.
So it's protected because of access to that file that contains
Right.
the secrets in etcd.
Right. Well, and the other thing is if you have source control behind your firewall, if you have a registry behind your firewall, and all your machines are behind your firewall, stick them wherever the fuck you want. Like, who cares? It's only if you want to be able to start like putting something out on open source something, or put something out in like a public registry, or run something out on Amazon where you don't quite know that you've really secured it right. That's when you need to start. Okay. Or you want to run it in a PAS, either someone else running it or something inside your org that someone else is running for you, where you don't know that you can trust everyone who has access to that machine. So it all depends. It also depends on what secrets you're keeping, yes. And the NSA has access to them all anyway, so whatever.
And you can encrypt it in etcd and just decrypt it inside your container or something like that.
Yeah, absolutely.
Right.
As long as you put an encryption key somewhere and don't put that outside.
Yeah.
Now you just need to find somewhere to put that.
Just use the last 7 digits of the
I like that. Any other questions, comments? Yes.
How far do you take during production? Like, so say you have a SQL Server production versus SQL Server, that you make the connection type the same? Like, let's say your TCP, you know, TCP as well?
Yeah, I try to. You just do it within comfort. And if you get too different, now you have to have different deploy scripts or different tools to write down your config values or whatever. So it kind of the more you keep the same, the more you use the same deploy scripts and the same tools to deploy. So the more you test them. If production looks exactly like in development, every single time a developer works, they've tested your production deploy scripts, and that's super powerful. And it also incentivizes your developers to not break things and throw it over the wall, because if they break something, right, they're not just breaking it for like a staging server somewhere, they're breaking it for themselves. And so it's actually, when you do that, you actually find developers actually start figuring out how to write cookbooks, start having to work on stuff, and hopefully you do less hand-holding.
So how long did it take you from, hey, here's my legacy app, oh, let me Dockerize it, and so someone who's starting wants to do this is just that first part, right? That was let's just take a little piece and Dockerize. It seems like it's a lot of effort.
Well, I mean, it can be a lot of effort, but like it's a lot of effort you do once, and then you're able to repeat. So when I did the Elk stuff, it was probably like 8 hours of work over like a couple of weeks, like when I had free time, because I'd kind of already figured out how to do most of the bits. I just had to tie it together. I already had the Factorish stuff figured out and a lot of the stuff done. But if you're starting from scratch, obviously it's going to take you some time. Hopefully what I've done or what someone else has done can bootstrap you and you don't have to start from scratch.
Right.
But you also have to kind of at some point understand what you're doing, because you don't want to run something in production you don't understand. And so at some point, like, you can bootstrap yourself and get yourself like debbing and testing, but you really need to understand the whole thing if you're wanting to run in production, if you care about it. If it's just some stupid app that you just want to run on Heroku to, like, I don't know, do silly cat gifs or something, then who cares? But you probably wouldn't be running that on a legacy app. Cool.
Raise your hand if the stuff that Paul was talking about for System D was your first time to see unit files.
Really?
A lot of people
See which
see the unit files, those fleet CTL unit files.
Oh, I haven't seen it.
Okay, so now, remember that one of the things I said was for the first 30 minutes of each of these each month, we're going to do targeted beginner tech talk. So would it be interesting to completely deconstruct the system D unit file, fleet CTL unit file, as a part of something like that, as well as just looking at the Docker image command and looking at what all the layers mean and how that maps to a Docker file. Ubuntu 14.04 is migrating to System D in flight. Fedora 21 is only System D. As much as I'm really gut-wrenched about it, it's, like Eric said,
System D is also forking their own kernel.
I'm not gonna float an opinion, but I will agree, what you said was a fact. It's coming, so,
Except on Amazon Linux.
yeah, except on Amazon Linux, for now anyway.
System 5.
Yeah, System 5. So, the,
There's other NS services that don't have to depend on system.
The problem is the OS is